In this lecture, we're going to learn about static members. And these are members that are not tied to any class object. They are going to be tied to a class blueprint itself. Let's look at what we have been doing so far. We have seen that we can declare a class like this. For example, we can have a class point here, and it's going to have a few member variables inside. Once we have this class, we can create objects of it. And for example, here we have 6 objects of class point here. So we have point 1, point 2, all the way to point 6. Each of these points is going to have its own copy of member variables. And they are going to be completely separate points. For example, the data we have in P1 is going to be different from the data we have in P2, and so on. So we might have a situation like this, and each point is its own point really. It has nothing to share with other points. And if you try to print the addresses of the member variables, you're going to see that they live at different memory locations because they are completely different data sets. So from this, we can really see that regular member variables are not tied to the class itself. They are tied to the object, and they belong to objects, and the object is going to completely manage that member variable. But sometimes we need a member variable which is not tied to any class object, and we want that to be tied to the class blueprint. Let me show you what I mean. Suppose we have our class point here, and we wanted to introduce a new member variable. And it is this little guy here, size t, and it is going to be point count. Its job is going to be to keep track of how many point objects we have. So we can't really keep track of this member variable in an object, because if it lives in an object, it's going to die the moment the object dies. We want this to live somewhere else. And C++ has a way to make this be managed by the class blueprint itself. And you do this by marking this member variable as static. The moment you do that, then you will have the possibility to really manipulate it at each object that you create. So for example, if we create point 1, we can increment that member variable to be 1. If we create point 2, we can increment it and make it a 2. And you can see that using this technique, we can really use this member variable to keep track of how many point objects we have created in our program. This is just one use of these kinds of member variables, and we make them behave this way by marking them as static. And we're going to see how to do that starting in the next lecture. But for now, note that these kinds of member variables are not going to be tied to any object that we create in our program. They are going to be tied and completely managed by the class blueprint itself. Now that you know this, let's head to the next lecture and see how you can do this exactly. Go ahead and finish up here and meet me there.